Hello guys, you are welcome to the GMAETS 41's live class, and in this class we are going to be dealing with some questions, right, as fast as possible in Math 102 UNIZIK workbook. The journey is still on. We are taking a ride through this course. We've got there about 44 questions in that workbook, all right, to deliver for students, to help them to be able to put their workbook together for submission. At least that covers 30 marks. Now, this class was not pre-scheduled, okay, because like I told you, friends, sometimes I could just come on live to do something. And we have very little time in this particular live class because there about 4 p.m. I'll be holding physical tutorial class on campus for GMAETS. So quickly, within the short time we have before I leave, where I am now at home to go to the campus in order to hold the physical tutorial, I'd like us to quickly look at question 22 to 25. Before now, we already covered question 1 to 21. So let us see what we have in question 22. We're going to cover 22, 23, 24, and 25 in this live class. So, question number 22 is based on differentiation if you have your workbook on Math 102 for GMAETS. I know some of you are already free, perhaps from lecture today, being Monday. And so, without wasting time, make sure you are connected to this class. Make sure you are connected to this class. And like I've always said, if you have not subscribed to this wonderful channel, which deep down in you, you know how great this channel is to helping students. If you have not subscribed, right away, hit the subscription icon. After subscribing, you would see a notification bell. Tap on that notification bell icon. A menu displays, you see, click on all so that once I upload any content or I come on live anytime, YouTube will send you a notification immediately that class is ongoing at GMAETS 41. Remember, subscription is free. Turning on notification bell is free. So do that. Don't waste any further time. They can become channel member to get even much more benefits by joining this channel on platinum level or gold level. You have the join tab on the home page or under any of GMAETS 41's video, you would see the join tab. Click on it, then you can become a channel member. All right, having said that, let us move on quickly. There is no time. Question number 22, we have if. Question 22, okay, if y equal to cos open bracket 3x minus 7, then find dy dx. So y is equal to cos open bracket 3x minus 7. We are required to find dy dx, and as always, this is 1 plus 1. This is 1 plus 1. In the manual, I don't think there was no defined pattern to follow as per how to solve this question, like step by step. No defined pattern was given to you. I think you were simply expected to solve this question. So you decide how you solve it. However, because this is something about workbook, which you are meant to submit, instead of using the markers, major, minor differentiation to deal with this just in one step, I will be using the general method, okay, which of course you'll be taught in your lecture halls, right? I'll be using the chain rule because this problem, to solve it, you've got to use chain rule, okay? But like I told you in our main classes, when I hold physical tutorial classes, or maybe in the online class when I'm teaching you differentiation, we have the video lessons already available on this channel. Are you following, right? What you would see there I use often is the major minor differentiation. I don't need to use chain rule in this. Using chain rule with respect to the format of exam you are taking is actually like a waste of time. Does that make sense? So, but for the purpose of your workbook, I shall be using the chain rule format. So the question given to us, we have y to be equal to cos open bracket 3x minus 7. I'm trying to check through the workbook to see if there is a defined pattern they want you to follow for this particular question, but I don't think there was any defined pattern. So that's question 22, right? Okay. No defined pattern for you to follow. Yeah, no defined pattern. So a box was created for you to solve inside that box. So we go. Starting, if I pronounce this is cos 3x minus 7. That's how the function is pronounced. So you begin by letting u to be equal to 3x minus 7. And someone will be like, why do I know? Or how will I know that u will be this 3x minus 7? It's simple. The major minor concept already explains that. If I say cos 3x minus 7, the question would be, what did you pronounce first? What you pronounce first is your major function, which of course in this case is cos. And then what you now pronounce next is your minor function, which is your 3x minus 7 as you have there. If u is equal to 3x minus 7 this term, it simply means that the function y will be equal to cos u. Now I have to differentiate this u with respect to x, because you see clearly that u depends on x. So let us proceed and obtain du dx. Du dx means differentiate u with respect to x. So you're only differentiating the x term there. So come to 3x minus 7, differentiate this 3x, simply differentiate this x. That's x raised to power 1 there. If you differentiate it, you get 1. I've always say this, if you have a variable in its basic form. And how do you know that a variable is in its basic form? If that variable is exactly the way it is when you are reading your ABCD. Are you following, right? If you're pronouncing x, it's simply x, and that's what you have here, just x. If you differentiate it, you're going to get 1. 1 times 3 will give you 3. Then minus 7, if you differentiate this 7, is a pure constant. The x that you're meant to differentiate is not there. So you're going to get 0. Kick that off. We are done with it. Next, we are going to differentiate y with respect to x. What I'm doing here is chain rule approach to solving, functions known as functions of functions. But you see, when GMAT 41 teaches differentiation and integration, I don't punish students with that concept. Functions of function, chain rule lets you be this. One interesting thing is that chain rule is the most powerful rule of differentiation. Yes. Everything you do in differentiation is chain rule modeled. But then the major minor differentiation concept is the classical interpretation of chain rule. So why punish yourself? Oftentimes, say in exam case now, you're solving the question, it lets you be equal to. I've said that time and again in my key video lessons on calculus. Come on, let go of that lets you be equal to whatever. And deal with it without letting you be anything. Anyway, let's move on. Here, I will differentiate y with respect to u because y depends on u now. So you have dy du rather. Dy du. Y depends on u. Differentiate y with respect to u. So what do? You say this u is already in its basic form. If you are reading ABCD, you get to u, you pronounce it as u. So anytime you have something like this, derivative of that function is simply for you to differentiate the major function. If I differentiate cos, I will simply get minus sine u. I've explained all these concepts in our physical tutorial and in our online classes on differentiation. Is that okay? So you want to take those lessons. Today, like I said, I think by 4 p.m., I'll be taking, differentiation. That's what we have in our class today. So you want to join the class, which I invite you to join. Yes, you will enjoy the fact that you identify with GMAT 41. This is the contact. Contact me on WhatsApp. Are you following, right? And then you can make inquiries about the GMAT 41's tutorials, physical tutorials, if you wish to join. Now that I've done this, I will now solve dy dx will be equal to applying chain rule to solving problems. If I want to get dy dx, it is simply du dx times dy du. Good. To get dy dx for this question is simply to multiply du dx by dy du. And if I do that, this is going to be equal to du dx from here is 3. And then dy du is minus sine u. But we know what u already is. Can I actually conclude this here? I think I can do that. Okay. Therefore, dy dx is equal to 3 times minus sine stuff here, sine u will give us minus 3 sine u is equal to 3x minus 7. This is cool. And of course, this is the solution to this problem. Is that okay? And this, if it is in exam hall, you could have just hit it straight on. One step, you get your answer. Use the major-minor differentiation concept. Like I said, this chain rule that I applied already. In real exam situations, say you are seated for objective, exam question that deals with options, CBT. You don't need all these things. They are waste of time. Just come over here, differentiate the major, differentiate the minor, and then you multiply. The minor is 3x minus 7. Differentiate it, you get 3. The major is cos. Differentiate cos, you get minus sine. Now, minus sine what? Because trig functions cannot stand alone like that. It's going to be minus sine of the original minor function. So what am I saying? If you differentiate this cos, you get minus sine 3x minus 7. Remember, when you differentiated 3x minus 7, you got 3. Now multiply it by the derivative of this major function cos. You get minus 3, minus 3 sine 3x minus 7. Where the 3 comes from differentiating the minor. And then minus sine 3x minus 7 comes from differentiating the major cos. All right, guys, I hope you understand this. And that is, pretty much stuff you should know about chain rule. I have a reason why I don't usually like that principle generally when it comes to exam. There are some type of functions given to you that applying chain rule might become so tough. It's not that you cannot apply it to solve the question, you can, but along the way, if you're not careful, you might make mistakes. Is that okay? Because that might lead you to define, let u be equal to that, let v be equal to this, let y now be equal to this. By the time you do all this, did this, did that, did this, did that, did the other thing, and multiply, you might just get lost. But the major minor function derivative solves the problem. Before I move on to question 2, let me check that the camera, is on focus and is in focus rather. And the network, at least, is not over disturbing. Rezard Lewandowski, what language is he speaking? I cannot understand him. I'm sorry about that, okay? I'm actually using English language. I'm using English language. Good enough. YouTube, has done something wonderful. It's a great platform. We have language translators now on things, some channels or whatever. GMAETS for the ones channel is also enabled for language translation. So you can use that. You can use language translation to get to understand, what I'm saying in English language, okay? Let us move on to the next question, question number 23, Q23. Without wasting much time, I'll be fast in solving this question. Let's see what we have in question number 23. And then the question goes this way. Find the equation of the normal. Find the equation of the normal. Equation of the normal to the curve. To the curve y equal to 2x squared minus 5x plus 1 at the point x equal, let's see, at the point where x coordinates, at the point where x coordinates, at the point where x coordinates is 1. So that is the question. We have to find the equation of the what? The normal, right? Find the equation of the normal. How do you get the equation of the normal? It's a simple thing to do. The equation of normal solution. The equation of normal is given as y minus y1 equal to, let's say, m perpendicular x minus x1. Now I'm using m perpendicular, this symbol here, I'm using it to represent perpendicular. Some people can use m2, right? Some can use m2, and then m1 is the equation of the straight line, okay? The whole idea of normal here is that you have a curve. This is a curve. Then you have a normal to a curve. That is a line drawn to meet that curve at 90 degrees. And how do you achieve getting that line? First, you should know the tangent to that curve at the given point quoted here. The point quoted is x equal to 1. X coordinate there is 1. So get a tangent through the curve at that point. And then from there, you can now get your normal. You know, with this straight line drawn through this point, this straight line is our tangent. The tangent touches a curve at one point. We can now easily get our normal. We can now easily get our normal, which is a line drawn to be perpendicular to that tangent. You know, was it on Saturday, last week Saturday, not this one, the one before this Saturday, in our physical tutorial I was explaining to the GMAETS 41's dear students on how to obtain a normal to a given line or curve. Say, that was in physics 108, yeah, practical, because there, under refraction of light, using rectangular prism or triangular prism, you know, you're going to measure a lot of angles. So I had to take my time to teach them how to get normals to curve and other lines. So the idea, if I give you a curve ordinarily, you cannot just get a normal to it immediately. You have to indicate a tangent through it. Anyway, that aside, why I showed you this is, before we get, each of them has its own gradient. Like this tangent now, the gradient is m, or you can use m1. Then this normal, which is perpendicular to that tangent, I'm taking the gradient to be m perpendicular. So if you have a problem like this, you want to get the equation of the normal. This equation now is the equation of normal. The equation of this one, the one perpendicular. For this tangent, the equation is y minus y1 equal to m, open bracket, x minus x1. Then this one is y minus y1 equal to m perpendicular x minus x1. So that is how it goes. For you to get this m perpendicular, you must have gotten this m. So let us quickly move on and obtain the gradient of the tangent through this x coordinate point 1. Once I get the gradient of that tangent, my problem is solved. Okay, my problem is solved. My problem is solved. Now, watch how we do that. I've tried to explain this concept, so at least you learn something good enough. But remember, for holistic learning, full understanding of this concept, you have to join either a physical tutorial class or you join our full online tutorials. Is that okay? On this channel, where you get, you know, the topic step by step, and you get to understand all these things that I'm just talking about and even more. Become a channel member to get access to our full lecture videos on your courses. Math 102, Physics 102, Chem 102, Physics 108, Chem 108, Stat 112 also available. Follow, and then Physics 104 also available on this channel. This is irresistible. When you do all these things, becoming a channel member, registering for full online tutorial classes, or maybe a physical tutorial class, you can be sure of one thing. Your A is certain. Yeah, it's certain. When you do the needful, nothing stops your A. And first class in view, awaiting you. So the first thing we're going to do, like I said, is getting the gradient of the tangents to this curve. And how do we do that? Simply go and obtain your dy dx. This is y function given to us. I'm going to differentiate this 10. Differentiate 2x squared, you're going to get 4x. Differentiate minus 5x, you're going to get minus 5. Differentiate plus 1, you get 0. Now, this dy dx is our tangent. It's the gradient, rather, of the tangent, right? Of the tangent line. Yeah, I can simply call it the tangent, because tangent is a straight line. Gradient is the slope of that straight line. So dy dx here is our slope. It's our gradient. I'll now obtain the value of this gradient at the given value of x, because this expression still contains x. Dy dx at x equal to 1. dy dx, which is gradient at x equal to 1, will be equal to, come over here, wherever you see x, you fix 1. And that's what I've done here. If you simplify this, your dy dx, which like I told you, dy dx, which is equal to m, the gradient of the straight line, will be equal to minus 1. We have gotten the gradient of the tangent to this curve. It is minus 1. Therefore, the gradient of the normal, whose equation we are asked to find, the gradient of the normal is minus 1 over gradient of the straight line, which is equal to minus 1 over gradient of the straight line or tangent line is minus 1 on its own. If we simplify this, our m perpendicular will be equal to 1. So we have gotten the gradient of the normal line. The gradient of this line, this normal line to this curve, we have gotten it, and the value is 1. I'm going to wipe this part of the board so that I would complete a solution. Now that the value is 1, what do we do from here? Simple. Proceed now and see if you have gotten all the things you need in order to use this equation. We have gotten m perpendicular. That's good. That is 1. We have obtained, okay, x1 was given to us from the question, which is the coordinate of x-axis. Are you following, right? But what about y1? We don't know. And it's simple to obtain y1. So I'll write also, but y1 will be equal to, come to this equation, you are going to use the value of x1, which, like I said, is this coordinate given to us. Use that value to obtain the value of y1. So y1 will be equal to 2 brackets, x1, which is 1, you square it, minus 5 bracket 1 plus 1. So that y1 will now be equal to, let's simplify this. 1 square will give you 1 times 2 will give you 2. 5 times 1 will give us 5. 2 minus 5 will give you minus 3. Minus 3 plus 1 will give you minus 2, right? Good. So we know our x1 and our y1. We know our x1 and our y1, so we can substitute into this equation. So now write at x1 comma y1, which is equal to 1 comma minus 2. That point where the normal touch the curve, the value of x there is 1. And for any x value, you can get a corresponding y value, you know. Like if you're plotting graph, you use x and y value to locate a point. So at that point where this normal met that curve, x value is 1. Y value there is minus 2. So you call that x1, y1. So this implies that at this point, you now use this equation. Y minus, in place of y1, fix minus 2. Then that's equal to gradient of the normal line, which is 1. Then multiply it by x minus x1. And x1 is 1. For this question, I guess the only place that a student might just be confused sometimes, if I had not explained it, is how would you get your y1? Yeah. And that is what I've just explained. Many of us would know that if you're given a curve, to obtain your gradient, you do dy dx. You get gradient. Are you following, right? Of the line that passed through the curve at a given point. But how to get your y1, because it was not given. In most cases, examiner gives you x1, y1 value. But here, the coordinate was not given to us. So it's meant for you to know this. That is why you have to take full lectures on all these, topics. Very important. I've always said that become a full registered member either in our physical tutorial if you are a UNIZIK student. On campus, there I run my classes there. All right. Today we have maths by 4 o'clock, maths 102. I'll be on campus, right? I'll be in campus very soon, just once I'm done with this class. And then you can also register for our full online tutorials, okay? Just always contact GMAETS 41. Then you can also become channel member on platinum or diamond level. The higher the level you join, the more benefits you get. Y minus minus 2 will give us y plus 2, and that's equal to 1 times this bracket to give us the term in the bracket. Now, there are various ways the answer of this thing can be presented, right? It is either all the terms are collected to one side and made equal to 0, or x and y term are taken to one side and made equal to a constant. or y will be made subject of the formula. I would like to make y subject to the formula because I want to get this answer in proper standard form of equation of a straight line where we have intercepts. So I will make y subject to the formula. That's going to be equal to x. If these two moves, you're going to get minus 1 minus 2, which will give us minus 3. So this is our answer. But like I said, or you may decide to say, let all the term be moved to one side. You'll get y, minus x. And then if 1 moves, this minus 1 moves, you get plus 3 on the left-hand side, then equal to 0, right? This is also a possible answer. Now, usually, your examiner chooses between any one of these two in most cases, right? But like I said, also, let's look at this. We could rewrite the result as y minus x, and then 3 moves to that side, giving us minus 3, which I could still say, okay, or if I multiply all this by minus 1, we could still get this to be x minus y equal to plus 3. All these are possible solutions. Are you following, right? All these are possible solutions. Answer, answer. These are possible solutions, how your examiner might give you the option. So finish up that. Let's move on to question number 24 of this. Finish up. Let's move on to question number 24. James 01, thank you for upgrading and welcome to join the class. Okay. So we are moving on. Please be fast. Time is against me now. This is 7 after 3. I'm living very far from campus. I just hope I will just appear on campus immediately, Finish this. Let me wipe this part of the board. Remember, at the end of this live class, a copy of this video will be made available. To be available, so you can always check back. Are you getting me right? And under that case, it's no, you can now control me. Maybe there is something, if there is something I said you don't understand, you can take it back. Are you following? That's the beauty of online learning. Allows you to learn at your own pace. I can tell you that so many people are testifying to the goodness of what this channel is doing for them, enhancing their physical learning. So please, make use of this online platform. You won't regret it. You won't. All right, I'm going to wipe this and then we move on to question number 24. I'm going to be fast. I think I explained so much, but it's because I love you guys. I love you people. I want you to get this thing for what it is. So you can also help to spread the information. How? By teaching other people who might be in need. There are so many people who need this knowledge. So let us move on to question number 24. Question 24. So what have we got there? Question 24. Let's see. Good. Question number 24 in the workbook, you are asked to find the stationary point. Find the stationary point. I'm sorry that I cannot track what is happening there. This device is very, very low, so I cannot stream from this device to know what is happening from your end. Sometimes I might just have to go and view the camera. Are you following, right? So let's follow up. If you have any question, you can come back at the end of this class, drop the question. But I could still come and check through the camera. If you see any question there, if I see any question, I'll respond. Find the stationary point of the curve. Find the stationary point of the curve. Y equal to x cubed minus x squared minus x. We have to find the stationary point. Whenever you hear stationary point, it is the same as turning point. It is the same as critical point. It is the same as steady state condition or point. All these terms, they mean the same thing, right? Does that make sense? Okay, so in case your examiner uses any of those words, they are referring to the same thing. So how do we get the stationary point of a function? It's simple. Differentiate that function, set it equal to 0, and then solve for the unknown. So here we are given y to be equal to x cubed minus x squared minus x. We shall differentiate this. dy dx is going to give us 3x squared minus 2x minus 1. I have differentiated this. So at stationary point, at stationary point, which I told you is the same as turning point. dy dx equal to 0. dy dx equal to 0. The implication is that 3x squared minus 2x minus 1 is equal to 0. I'm pretty fast, right? There's some people think that I cannot teach very fast. Damn, I am super fast if I want to do that. But I want every one of you to get at least something good whenever you come for the GMAETS 41 classes, right? But this question, I'm going to be fast. There are no two ways about it. I've differentiated this function given to us. This is what we got, okay? And I told you at stationary point, simply set that first derivative to 0. And that's what I've done here. So this becomes a quadratic equation, which we are going to solve. I'm sorry, at GMAETS 41, I don't spend time solving quadratic equation. There's a fast approach of obtaining it. So you watch as I do that, so we get the root of the equation. The question simply say you should solve, right? Okay, you should find the stationary point of this function. Okay, so to find the stationary point, we are going to factorize this quadratic equation. And how do we do that? Use this coefficient of x squared to multiply this constant term. 3 times minus 1 will give you minus 3. Find two numbers, which if you multiply, you get minus 3. And if you add them, you get minus 2. What are the two numbers that will do that? Right? The two numbers that can do that, if you multiply those two numbers, they'll give you minus 3. And then add them, they'll give you minus 2. Those two numbers must be factors of that minus 3. So the numbers that will do that will be minus 3 and plus 1. I repeat, minus 3 and plus 1. Do you get that? So if the factors that can solve this problem are minus 3 and plus 1, the value of x will now be, I mentioned minus 3. That minus 3 change the sign. It will become plus 3. Then divide it by this 3 that you have there. I repeat, one of the factors that can solve this problem is minus 3. What do you do to it? Change the sign, you will get plus 3. Divide that plus 3 by the coefficient of the guy carrying x squared here. So one of the value of x here is equal to 1, because 3 over 3 will give you 1. Or the second stationary point is, go to the second factor, which is plus 1. What do you do to that plus 1? Change the sign, you will get minus 1 and divide by the coefficient of the guy carrying x squared. So the second stationary point value of this function is going to be x equal to minus 1 over 3. And of course, we are done with this question. Okay? We are done with this question. These are the stationary points. It means that this curve, if you are moving along it, at x equal to 1, there is going to be a turn. If you are plotting the graph now, let's say it's going this way, it's going this way. At x equal to 1, the curve will, as in the line, the graph will curve. Either curving down or curving up. Don't worry, I'm not going to talk much about that. Then at x equal to minus 1 over 3, again, the graph will change direction again. So there is going to be another curve, a turning point. So that is it. We are done. I will meet up quickly. That most times is very difficult to get transportation from my end to campus. So let's round up the last question. No time. I usually like covering what I want to deliver in any of our lecture. So the last question, the velocity of a particle moving on a straight line is given by the velocity of a particle. I'm sorry, I won't copy the question on the board. The velocity of a particle moving on a straight line is given by, so look at it, v equal to 40 all over t plus 1. The velocity of a particle moving on a straight line is given by v equal to 40 over t plus 1. And then the manual requires that we find the acceleration of the particle. So acceleration, we don't know. Acceleration, I'm going to use A. We do not know. So this is one application of differentiation. Even this question 4 is also under application of differentiation. On this channel, you have a video lesson also specially dedicated to applications of differentiation, the various aspects, that differentiation can be applied. Become a channel member. I repeat, become a channel member. You can also register for our full online class. Like I said, the higher you apply for our online works, right, the more benefits you get. All those who applied to or joined the diamond level on this channel, please contact GMAETS 41 on this number. contact GMAT 41 using that number. Contact me on WhatsApp because there is an extra benefit you are meant to get. Someone has already contacted me earlier who is a diamond member, and the person, you know, has a wonderful access to something, right? Like I said, the full solution to this workbook and many more benefits there, right? Because here I'll be solving this thing, whether or not the time given to able to submit this workbook is closed, and I'm going to solve accordingly. I'm not rushing anything. If you want to get all the solutions, become a channel member on diamond level, right? But just pray that I'm able to cover all of them within the space of time left, especially for those on platinum. Okay? We are moving, at least we are doing some great job. This is 25 questions already in your Math 102. That'll be small thing. So we are asked to find the acceleration of this particle. Did they specify the point at which we should find the acceleration? No. The question just says get the acceleration. So solution, you know, in physics, under motion, because this kinematics motion problem, an application of differentiation. Acceleration A is the first derivative of velocity. That is differentiate velocity with respect to time, which means we are going to differentiate this term here, right? Our A will now be d dt, that is differentiate with respect to time, whatever the velocity function is. And the velocity function is 40 all over t plus 1. So we have to differentiate this. Now, there are two ways you may choose to differentiate this. You can use quotient rule to solve this problem. Why? Because this is in fraction form. It's a rational function. It has numerator and denominator. So you can use quotient rule. Good enough to solve the problem using quotient rule already, right? In this manual. Where in that case, you keep t plus 1 constant, differentiate this 40, minus keep 40 constant, differentiate this t plus 1, then all over, you square the denominator. Simplify whatever you have there. That is one way you can solve this problem. Alternatively, you might solve this problem using standard derivative approach because that can also solve it. To achieve that, we have to rewrite this 40 over t plus 1. We have to write it. This is the same as differentiate with respect to time. This time you are seeing the same as 40, open bracket t plus 1, raised to the power of minus 1. Good. It's the same as that time. Just take t plus 1 up. It becomes raised to the power minus 1. So I want to use this to solve it. Our A will now be, do your major minor differentiation, you know. Start by differentiation from outside because this is the major function, that minus 1 there. You're going to use that minus 1 to multiply 40 and then you get minus 40. Open bracket. Then copy that t plus 1. Go to the power and subtract 1. You get minus 2. Once again, use the power, multiply the base, go to the power and subtract 1. Standard derivative, rule number 1 per se. If you want to talk about cramming, but you don't need to cram all those. Number 1, rule number 2, you don't need that. Just know the standard derivatives. And here on this channel, I have video lessons that deals with all those things. I've treated this part also in a physical tutorial class. We are continuing with differentiation today by 4. Like I said, this is 319. Okay, so what I've done here, I've differentiated. I am meant to multiply this thing now, go to this minor function t plus 1 and differentiate t plus 1. But if you differentiate t plus 1, you are going to get t. Come over here, differentiate this t, you get 1 rather. If you differentiate t plus 1, you get 1 rather. When I did this external differentiation, I am meant to move in and then differentiate what you have inside, t plus 1. Differentiate t, you get 1. So this is going to be times 1. Differentiate this 1, you get 0, it goes off. You know, this gave us 1, and it's a waste of time by doing this because this t is already in its basic form. If you are reading ABCD, you get a t, you pronounce it as t. So if you differentiate this t alone, you get 1. Major minor derivative. This differentiation here is the major derivative where I use this power. And then the minor derivative is this 1 I obtained here, differentiating this variable. Like I said, it's a waste of time doing minor derivative here because this variable t is in its basic form already. 1 times anything is that thing. So our A is equal to 40. Using this law here, this is the same as 1 over t plus 1. 1 over t plus 1 raised to power positive 2. Negative index law of indices. If you work on that, this whole term will give us t plus 1 in bracket raised to power 2. And that, of course, is the solution of the acceleration answer. How about I quickly do something, but I'll wipe it here. That product rule stuff, I've already explained it, because if you use product rule to solve this, it will still be fast. Nothing will be there. Let me show you quickly. Or, is it product rule I said, or quotient rule? Or by quotient rule. Quotient rule. Let's see if I can squeeze it here. Here, you're going to keep, our A will now be equal to keep the denominator constant, which is t plus 1. Differentiate the numerator. If you differentiate 40, you're going to get 0. Then minus, keep the numerator constant 40, differentiate the denominator t plus 1. If you differentiate t plus 1, you're going to get t. So at this point, divide everything by square of the denominator, which is t plus 1. That is it. I hope this has not cut off from view. I hope it has not cut off. Okay. So let me adjust this back a bit so as to capture. All right, that is good. So in conclusion, acceleration will now be t plus 1 times 0 give us 0. So that term goes off. I omitted minus here. I'm sorry. There's a negative. Look at it. There's a negative as you're solving. So t plus 1 times 0 give you 0. It goes off. 0 minus 40 times 1. 40 times 1 is 40. 0 minus 40 will give us minus 40. Then divide by t plus 1 raised to power 2. So you see that we got the same thing, right? Good. We got the same thing. And that is how we have come to the end of our class today. And I hope you learned something from this. Tonight, I'll be dealing with further aspect of your physics 102, because we have physics 102 online class this evening. I'm going to be dealing with, we're already in chapter 2 from question 4. We're going to be dealing with question 4 to 6 this evening. So make sure you stick around so you don't miss the class. Enjoy the rest of your day while I move on to the next phase to meet with our dear registered students in our physical tutorial on campus. I look forward to seeing as many of you contact GMAETS 41 on WhatsApp, right? And make inquiries about our tutorials, whether for the physical tutorial or for the online class. Please take note. If you want to make that inquiry, contact me on WhatsApp. That's the contact on the board. Does that make sense, right? Okay, so I also look forward to having you, friend, become channel members, right? And once you register for our physical tutorial, you also get automatic access to all our online platforms, both on YouTube, on Telegram. Is that okay? Yeah. Like I say, so many benefits for becoming a full member. However, you can also join the platinum level, the diamond level also. Okay, guys, I've got to go. Enjoy the remaining part of your day.